Hello, and welcome to Prototype and See, the podcast for designers, engineers, and innovators all about the product development journey. My name's James Murphy, co-founder of HLH, one of the world's leading manufacturers of prototypes and bespoke production parts. And in this series, we'll be sitting down with some of the world's most innovative companies to discuss and find out how they go about bringing new products to life. So today we've got Justin Mitchell, who's a mechanical engineer from Yamaha Motor Corporation in Atlanta, Georgia. Hello, Justin. How are you?
Hey, I'm good. How are you?
Yeah, not too bad, thank you. So thank you for coming on. Could you just, just to start, if you could just kind of introduce yourself, tell us a little bit about you and who you are and what you do.
Yeah. Right now I'm like a mid-level engineer at Yamaha. I work in the watercraft group, so working on designing stuff for, be it the wave runners. Most people would know it as jet skis, but we don't like to say jet ski because jet ski is like Kawasaki's trademark name.
Oh,
So
okay.
it's kind of like a Kleenex type of thing.
Okay, yeah, that's the first I've heard about that. Right, so jet skis Kawasaki.
Correct.
So what are you guys?
We're Wave Runner, which
Wave Runner.
Kawasaki kind of started that segment, which is ironic because right now I think they have less than 10% market share. But,
right.
Yeah. So, working there right now, I'm working on in the accessories group. So we work on what you could consider as almost like packages on a car, but for the watercraft vehicles. And then I work predominantly on those wave runners, but we do a little bit of stuff for the Yamaha boats and stuff, whatnot too.
Okay. So the engines on the boats or the whole?
No, we don't work on the engines. The engines come from Japan, and then in the US, we do the vehicle design and all the different aspects that would go into that. Or on top of that, which is kind of what I do, which is like I said, accessories. It's almost like the packages. So outfitting the different vehicles for different objectives, be it fishing, touring, or like performance oriented stuff for racing applications or whatever.
Okay, so Yamaha is a Japanese company.
Correct. Yeah.
But the design for the wave runners is all done in the States.
Correct. Yeah, everything except for the engine and some of the programming for the engine, like in the ECU and everything, which would really be considered part of the engine assembly. So that all comes from Japan, and they're assembled and built in Georgia, as well as designed in Georgia.
Right. How Japanese would you say like the kind of working environment is, or is it not at all?
So I work in we have a huge office in this area, but then I work in a smaller office that's more for R&D and engineering, and I'd say it's like a little more US there. Overall, I think Yamaha US is a pretty US thing at the end of the day. I think that a lot of the Japanese companies, I think you could see a similar thing happening with Toyota. They've realized that in Japan, they're really good at reliability, production, making sure everything is repeatable, but they've realized that they're not necessarily good at innovation, especially when it comes to competing in the US market. So you've seen companies like Toyota and Yamaha doing the same thing of wanting to move into the US when it comes to new product development.
Okay, and why do you think that is? Why do you think they're less good at that? Just because they don't think the same way as Americans do?
I don't know. It's like hard to say for sure. It's not like completely black and white. Like obviously some Japanese people are very good at innovation and some US people are good at quality and things like that, right? But I don't know what I know their educational system is very different. So I don't know if that plays something into it, but I don't know. But you see a lot of Japanese companies doing that right now.
Right. Yeah, and I guess the States is the market for wave runners.
Definitely.
Yeah. Okay. All right. So you've had a pretty kind of interesting, even though you're still quite young, you've had quite an interesting career so far. So you started out at Wahoo Fitness, I believe.
Yeah,
What were
I've
they
been
to you?
very like blessed, I think, throughout my career, even though I'm still very young right now, and that I've gotten to work on things that I've really enjoyed. So Wahoo Fitness is a company that sells products in the premium, like primarily cycling. So be it mountain biking, road biking, but also triathlon and touching on running a little bit now.
Okay.
And I was very I've raced bikes like basically my whole life, be it mountain bikes and
Right.
all that. So I was when I came down to Atlanta to go to Georgia Tech, I basically just I knew they were down here and I kept emailing them and I was like, "Oh, give me an internship, give me
Okay.
an internship."
Okay.
And then
Yeah.
finally got on. So worked there part time for about 6 years through college and a little while after. And then switched over to Yamaha, which was another place that kind of aligned with my interests because I grew up on dirt bikes and everything. And Yamaha's a huge brand for that. So I've
Uh-huh.
been able to work on things that I've enjoyed, which has been definitely a blessing.
Yeah, yeah, yeah. Okay, I think what we're gonna talk about today is some engineering advice that you wish you'd had earlier in your career, and hopefully things that'll help other kind of young engineers. So I think you've got four things that we're going to discuss. So one is the rate of learning is your biggest advantage. The second is the speed and capital efficiency is more important than having a big budget. You got number three is having a personality, and if you've got one, then you're already winning. And number four is AI, and how if you're not already kind of using it, you're already putting yourself at quite a big disadvantage. Okay, so if we look at the first one first, okay, rate of learning is your biggest advantage. So could you talk to us a little bit about that? What do you mean by that?
I think that engineering, I find that you kind of have to know how to go down rabbit holes.
Mm,
It's always, you're a problem solver at the end of the day as an engineer. And,
uh-huh.
knowing how to go down a rabbit hole and knowing what threads to pull and being able to pull on previous experience, being able to do that as quickly as possible. It's like I think somebody, I can't remember who it was, but they defined like intelligence as rate of learning. So
Right. Right.
I think that's a good way to look at it too, because then it's
Yeah.
it's hopeful too, because it's not, you can define how intelligent you are based off of how willing you are to learn and not necessarily how
Uh-huh.
much you know already. And I think
Yeah.
just always being willing to pull those threads and go down the rabbit hole. And I've found so many times throughout my career that like some rabbit hole I went down that was a complete dead end like a year ago, all of a sudden like came up in some meeting and you actually know something about it.
Yeah.
And
Yeah. Yeah.
yeah,
So just kind of keeping yourself open to all different ideas and approaches, and not being afraid to follow things and see where they lead.
definitely. I think that's important. And I think another thing that when it comes to rate of learning is I think for some reason a lot of engineers seem to be really frugal, and it doesn't necessarily take a lot of money, but I think being willing to invest in yourself a little bit, be it like
Yeah.
a new 3D printer or a new something that like a new 3D printer, maybe like a software package that you want to try and learn and see if it helps you out. Maybe it's like $15 a month. And a lot of times you
Yeah.
can get
Yeah.
your employer to pay for it, but even if it's just at home in your free time, like or a little course, maybe a little course is like $20 to go through it. It's just little things like that. I think are
Yeah.
are
Just
really
keep
worth
keep
it.
invest keep investing in yourself.
Definitely.
Yeah, I think like Warren Buffett was he said something along those lines, and like the best investment you can make is in yourself.
Yeah,
Um,
and I think that's definitely true.
yeah. So I think you said no product idea lasts very long with you before it touches a 3D printer. So you're quite a big fan of 3D printing. You like to.
Yeah, I am for some reason. I kind of got into it sort of early when it was kind of hobbyist. I was actually in high school at the time, but it was in 2014. One of my math teachers had put together like a kit 3D printer, and he let
Right.
me print some stuff on it, and that's when I kind of learned CAD and everything.
Okay.
But now, like everything everything we design at Yamaha, everything I do outside of work, it's like instantly like sketch it out, CAD, 3D print it. It's just the quickest way. I mean, the material is essentially like free at this point. It's gotten so cheap, and it's the
Right.
quickest way to validate anything. Even if it's
Yeah.
going to be a CNC part, like just make sure
Uh-huh.
there's no interferences, make sure it looks like you can assemble it and everything with the plastic part before you spend money on a CNC part.
Yeah. What about
Yeah.
some of the limitations though? What limitations do you find there are with 3D printing?
Yeah, I think you get a lot of people like you do. It's just, I think the biggest misconception I've seen with 3D printing is people that don't know too much about it. They think it's just like a magic machine and they're like, oh, 3D printing. But it's just like any other manufacturing process where you
Uh-huh.
have to design for the limitations. You have to understand how it works, what sort of
Mm.
geometries it works well with, which ones it doesn't. I mean, it has less limitations than a lot of other manufacturing processes, but it's still not, you know,
Yeah, yeah. It's not a catch-all. It can't do everything.
right.
Yeah. Okay, but yeah, I mean, you guys at Yamaha, you use quite a lot of 3D printing.
Yeah. Yeah. We go through crazy amounts of filament. The majority of it is FDM, and they're not production parts. It's, helping you kind of get your ideas out in the real world and test things
Yeah.
out as quickly as possible. We do some resin too for like finer details, whatnot.
Uh-huh.
If we need to do a lot of times we'll order MJF parts. We don't have in-house MJF capability, but a lot of times we'll order those for testing scenarios where we need,
Mm.
more uniform material properties and everything.
Yeah. Can you see it being used as a production process
I've
though, or
I've been
do you?
trying on a few projects just because I'm a fan of it. I've been
Uh-huh.
trying to see, especially actually, it's starting to get closer to where it makes sense, especially on what I'm working on, which is accessories. So it's not
Yeah.
like every single unit is not going to get this part on it. They're packages for like niche applications.
Hmm.
And that's where it's starting to be like maybe it could work, but I've been quoting some through and it's still not making sense at the volumes we're at. We're still resorting back to injection molding and stuff like that.
Right.
But
So I
I,
mean,
I think it's
it's
going to get
still it's
there.
still quite high volume stuff
Yeah.
you guys are working at. Yeah. Okay,
Yeah.
but
It's
you
still
you
fairly
can
high
see it
volume.
one day. One day, you think it'll be competitive.
I think we're getting close. I know some of our lower volume accessories are in the thousands, but they're
Right.
not they're not tens of thousands. There's thousands, and
Yeah.
that's where it's starting to get kind of,
Right.
if something were in the hundreds, it actually would make a lot of sense. But
Yeah.
the thousands is that we're close, but it's still injection molding still makes a lot more sense at that point. And I don't
Yeah.
I
And
don't know if
is it just
other
the cost? Is it just the cost of injection molding, you think? It's
it's a
in terms
little
of like the look and feel of the parts. You feel the 3D printed parts are good to go. It's just a
I
cost
think
thing.
with a MJF or an SLS process, it would pass fine through production. There's a few concerns. One, being in the marine environment, there's a lot of UV exposure, and
Right.
they're
Yeah.
ironing that out on a lot of those. But sometimes it's not good, so the parts would have to be painted or something. Another
Hmm.
weird thing is like, of course, you don't have the tooling price. So if you amortize that out, then a lot of times 3D printing it starts to look really good at those volumes. But I have noticed as
Mm.
well that I don't know if all companies are like this, but Yamaha, the way they like to do their investment structure, a lot of times they wanna just pay for a tool, knowing that
Right.
they can get a higher return on that piece price, and they're not actually looking at the tooling amortized out into the piece price. They're just
Okay.
looking at,
Yeah.
can
Yeah.
we
They
make
just
this
see that as
capital
kind of one
investment?
off. Right.
Yeah.
Right. Okay. Okay. Yeah. So that I mean that's going to make it a harder sell, I guess, into if they're looking at it like
Yeah.
that.
I think we're
Yeah.
getting there. You know, the world's changing, but it doesn't always
Yeah.
change as fast as we want it to.
No, no. And then in terms of prototyping, what other kind of processes do you guys like to
We
use?
do a lot of CNC parts, of course. A lot of CNC aluminum, stainless steel, all that. We recently got like a a pretty nice like router table. It has coolant and everything, so I've learned some cam and everything to
Okay.
run that, which is cool because we do prototype a lot of stuff where it's kind of like 2.5D geometries, where it's like depth cuts
Right.
or through cuts. So we do a lot of that, but we also outsource a lot of CNC parts.
Okay, and what are some of the common kind of pitfalls that you've seen slow down both the kind of you and like other engineering teams, and how can they be avoided in terms of the prototyping process?
Yeah, I've definitely seen a lot a lot has changed in that I've been at Yamaha, and that when I first got there, they were using Stratasys machines, and the
Hmm.
material is really expensive. The machines are really expensive, so we didn't have many of them. And
Uh-huh.
and people would almost like treat it like going to tooling or something, where it's like they have a prototype thing, but they wouldn't print it because either like the machine wouldn't be available or the material cost so much. It was like, I don't want to spend $300 on this thing, just
All right.
to put it on my desk and feel it with my hands. Where we've moved way more towards prosumer type machines, and now our materials like $20 per kilo, which is basically free. And so people are
Yeah.
doing way more just like slapping stuff together, trying things, throwing things at the wall to see what works. Um,
Yeah. So kind of keeping the costs down has allowed the team to be more kind of free to
Yeah, and
prototype,
it's
to
it's not like
iterate.
we're not afraid to spend money. It's just like getting that little bridge to where you're willing to spend money on a higher fidelity prototype, but you don't want to jump straight there because there a lot of times there's a lot of iteration just right there, and like iteration of like within 3 hours of like, oh, I printed this, but then I realized that this doesn't fit quite right, or this actually doesn't look as good in person as it does
Yeah.
on the screen. And also that iteration with the way it's structured at Yamaha, we have the engineers work very closely with product management, who's kind of planning the
Right.
products and setting up the business case, and being able to iterate with them as well within a span of a few hours of like do a little bit of CAD and print something out and show them. And maybe it wasn't exactly what they were envisioning for the product. Like they're not, as technical as engineers. So
Yeah. Okay, that kind of moves us on nicely to the next piece of advice, which was the speed and capital efficiency. They're more important, you feel, than having a big budget. So can you talk to us
yeah,
a little bit about
yeah, I've noticed that for some reason, a lot of engineers, it's like at home, they're like very scrappy and they'll build all these things at their house or as a hobby and spend virtually
that?
no money on it. And it's like
Yeah,
great little prototypes and tests and everything, but then they go into work at like a bigger company, and because they're not spending their money anymore, for some reason they just want to buy like these crazy expensive prototypes and do soft tooling and all this stuff. And it's
yeah,
like you can still vet your ideas out the same way. And they always want to buy the nicest machine and all that, but
uh,
it's I don't know. For some reason, I have this mentality of like, I'm not trying to spend a company's money how I wouldn't spend my own. And if I can,
yeah.
you know,
Take a little bit more of the kind of at home, do it yourself approach, and use that in the
yeah,
office, in the working environment. Yeah, and
yeah,
you can get quite a lot done like that faster,
faster,
maybe.
definitely. And
Yeah.
even when it comes to just, it's not like we're not taking that next step, but maybe we want to iterate a few times before we do take the next step and order higher
Yeah, I
fidelity
guess
parts.
it allows you to trial different things, to try out a couple of different options, and then get maybe quicker to one way you'd like to go forwards, and spend a little bit more
Yeah.
developing it. I guess, yeah.
I feel like
Okay, and then
those are the two just most important variables in product development that I've seen,
right,
is kind of just how fast can you do it and how
yeah,
affordably can you do it.
yeah. And even in like a market like yours, it's really important to move quickly.
Definitely, because things are always changing. The economy is changing. What people are looking for is changing. People's interests change, and it's faster than
Yeah,
ever too. Because of the internet, people get into some new niche thing, and we want to get a
yeah,
accessory out there where they can have a better experience doing that thing with their Yamaha product. And
right.
the faster we can get it to them, the better it is for them, and the better it is for us.
Yeah, yeah. Okay, okay. And then your next kind of piece of advice was having a personality is crucial. So, can you talk to us a little
Yeah.
bit about that?
I think you guys saw that maybe on I think I mentioned it in one of my LinkedIn posts. And
Uh-huh, uh-huh.
I think I was giving somebody advice. Somebody had reached out to me asking somebody coming out of college about engineering and how they was communication important, and I was
Yeah,
well, you're communicating with me. Honestly, if you have any personality at all, sometimes you're beating a lot of engineers. We tend to be pretty weird introverted types, and I'm not excluding
right.
myself in that at all.
Right, right. Okay, okay. Yeah. All right, fair enough. Yeah. Okay, and then AI. So obviously that's all the rage at the minute.
Yeah.
And yeah, how are you guys using it? How currently?
I use it a lot. Like I have Chat GPT and all that up open all the time. I mean, that's the most base level. We can get to more,
Okay.
but I mean, I have it up all the time. I do almost all of my research on there. It just seems so much
Right.
faster than I can find something on there in 15
Mm.
seconds, and it would take me 15 minutes to find it on Google. It's
Yeah.
so good at summarizing information. If you put in there like I want the material properties of nylon and I want to compare it to ABS and cost and this and just
Yeah.
tell it all the things you want, it'll put it all in a table just perfectly in 15 seconds. It would take 30, 45 minutes of googling that to,
Yeah.
get the right
Yeah.
values and do it yourself.
Yeah. Are you not worried that maybe the information it's giving you is not right, not
Well, it's gotten
correct?
pretty good at citing its sources now. Like it'll put the little
Yeah.
footnote on there and you can usually click on it and see where it's getting it from. And I mean, I've wasted enough time on Google in the past to kind of know where the good information's coming from. So
Yeah.
I guess
Yeah.
maybe in the future people won't know that as well, but hopefully it'll get better by
Uh,
then too.
okay. So have you got any kind of like top hacks for using AI in engineering? Is it
That's a really good one, is definitely for material properties and all that. It's also very good at estimating costs of things. You can tell it how much a
right?
part weighs and the materials and stuff. And it can even estimate like tooling costs sometimes, which those are a little
Right.
hit or miss, but it's pretty good
Yeah.
at
Yeah.
estimating costs. It's great at summarizing material data and tables. It can even do things like it'll make you like if you type in a product or whatever, it'll make you like a DFEMA even. And I
Right.
mean, those are excruciating to make. So
Yeah. Yeah.
being able
Yeah. Yeah.
to at least just have a good starting point. I found like that's the best thing with AI is it's so good at just getting you to 80% and you can do the last 20% yourself. Um,
Right.
and I think
Yeah.
that's especially true with coding and everything. I have a background with a lot of coding in college and stuff. And yeah, I've noticed that AI is really helpful in that sense. And also, I think another great thing to point out for mechanical engineers is if you don't have much coding experience, like you can be a software engineer with ChatGPT. That may be
Right.
not a very good one, maybe, but you can
Yeah. Yeah.
definitely make stuff work, especially from a firmware standpoint. Like mechanical engineers should not, no, definitely not be afraid to integrate some electronics and stuff in their prototypes. You
Uh
can
huh.
get the Chat GPT or whatever your one of choices. You can get the code running, no problem. I mean, if you have basic problem solving skills, it's no problem to get your prototype hacked together with some software on there.
Right. Okay. And are there any elements of design and engineering where you kind of against using AI to help?
We do have to be a little bit careful, I think, about I am very cognizant of, you have to be careful with your company of like what's data protected and what's not. For instance, if
Okay.
I'm typing anything in there that's, a product that we're working on or whatever, I'm going to use our enterprise data protected one, which is Copilot through Microsoft. So
Right.
you do have to be
Right.
kind of careful on that sort of thing. The
Yeah.
most the most interesting area that it's all going is like, what is it going to do for mechanical design in terms of CAD and everything?
Yeah. Yeah.
Obviously, like the topology optimization, all that's already out there, and that's really cool. But when are we going to get? And it's not a question of if, it's when are we going to get to the point where you can start doing this like text to prompt 3D model generation, and not like video game assets, but like actual parametric 3D CAD. And
Yeah.
and we're I mean, there's a lot of companies trying, and we're definitely kind of getting there. It was only about a month or two ago, I think. I was working on something, and I was doing a little bit of research on it, like what the key variables were, and trying to get my thoughts together. And
Uh-huh.
Chat GPT was actually like, "Do you want me to make a 3D model of it?" And I was like,
Right.
"Whoa!" And it actually
Yeah.
prompted me, and I was like, "Yeah, make one." And it used like the OpenSCAD backend, and it made a STL of the thing. It was like Roblox looking terrible, but it actually understood what the key variables were, made those variables, and made CAD based off of it. It was nothing you would ever use, but the fact that they're
Yeah.
trying, and it's not going to get any worse than it is now. It's only going to
No,
get
no,
better.
exactly. It can only get better, yeah. So what happens to your job then when that happens? Do you think, are you
I
worried
think it'll
about
be the
that
same
or
thing that's happened with
yeah?
software engineering, where you're able to just jump like, you know, jump to step 8 out of 10 rather than doing step 1 and 2 and 3. You just jump to
Yeah.
step 8, and then step 8, 9, 10 you do. And then you can just
Yeah.
do more products faster, and they'll just be just more leverage at the end of the day. Um,
Yeah. So you, I mean,
I'm not really afraid of it, but
you're not worried, no? You're not worried. You
I don't
you
think
think it'll
so.
just speed things up and make your job
Exactly.
faster? Do you think it'll mean that like ultimately like less engineers are needed? Or
Um, I think that's kind of like the AI. That's the whole AI argument. I don't know if it's cut and dry. I think that some companies will just do more
yeah.
with the same amount of
Yeah.
engineers. They'll expand into more markets. They'll create more products. They'll get more done quicker.
Mm,
And another
mm,
thing too is maybe their products will be more customized because it takes less
yeah.
work. So there'll be more options, and 3D printing and all that will only help with mass
Help with that as
customization of
well. Yeah.
products.
Yeah. Uh,
Um,
okay. Okay. So other than the kind of text to CAD model, are there any other like exciting AI developments that you're seeing on the horizon? Or
this isn't necess- This does lead into back into AI, but this isn't necessarily an AI specific thing I've noticed. But I feel like there's almost like this is more of like how the internet is starting to impact mechanical engineering, in my opinion, is that it's almost like what Spotify did to the music industry or YouTube did to the entertainment industry. I feel like
okay.
the barrier to entry on mechanical engineering and prototyping and even getting products to market has just come down so low. Like CAD software has gotten a lot cheaper. 3D printing
Yeah.
has gotten so affordable, so accessible. Um, the ability just on the internet to be able to reach out to different prototyping suppliers, be it you guys, be it your craft clouds or whatever, is anybody can sit at home with a laptop with connection to the internet, learn
Yeah.
how to design something, design it at a very, very, very low cost, if not free, source it, get parts from anywhere in the world, get them into their house. I mean, the barrier to entry is just so low. And I don't think it was that way 10 years ago. And I don't even
No,
think it was really that way 5 years ago.
no, certainly not. No, like you say, as the barrier to entry has dropped quite considerably. But is that a good thing? Do you think? Does the world need more product, or
I've
does
heard the
it need?
opposite argument of, people are just going to make more junk out there.
Yeah, does it
But
not? Is the world not crying out for less, better
yeah,
designed products
I don't
rather
know.
than?
I think it's almost a good thing because, if you go that route, say your independent designer puts something out there, it's 3D printed, you know, 10 people order it and nobody else
Yeah,
wants it because it's not actually that good. Well, they
yeah.
only made 10. But if you
They
go
only
your
made 10.
old route of some big company with product management says, we're going to make this little widget. And then they
Yeah,
do injection molding, they do tooling, they put 15,000 in inventory. Turns out nobody wanted it and they sell 400. You actually ended up with
yeah,
a lot more junk that way than you do the other
yeah,
way.
yeah. I guess that's yeah. It's, like you say, ultimately it could end up reducing waste.
Maybe.
I guess, and yeah,
But
yeah,
I think it gives a lot of hope to a lot of people that if they have an idea, I think
mm,
nowadays with AI, the internet, the way everything is just connected, if you have an idea, you can really make it.
mm,
It might take you
yeah,
a little while to figure it out, but if you have an idea, you can figure out how to make it, and you really don't need to spend that much money.
yeah. Well, I mean, with that in mind, then, like, do you still see value in people like spending all that time and money going to university to study engineering, design, and product development, things like that, or would you say to them maybe don't bother and just use ChatGPT, see what happens?
That might be a little extreme, but I do think that in 15 or 20 years, the importance of going to college will definitely have decreased. Right now, I haven't seen like any mechanical engineering jobs that don't require a mechanical
A degree.
engineering, piece of paper.
Yeah,
But
yeah,
I know software engineering, there's now a lot of companies that are hiring and don't necessarily require, you could have done some coding boot camp or whatever. So
yeah,
I,
yeah.
I think what's happened to software is maybe a leading indicator of what might happen with hardware in the next 10 to 15 years, maybe.
Okay, okay. All right. So have you got what advice would you give to people who are just kind of starting out now on their kind of product development journey? Have you got a couple of
I
pearls?
think the best thing I could say is kind of just what I just did, which is that the barrier to entry is it's so low. You can figure out how to design. You can go on YouTube. You can figure out how to design something. You can research something. You can do the CAD on your computer at a very low cost. There's tons of free CAD programs that are actually really good. 3D, the barrier to entry on 3D printing is so low. You can go to your local micro center and buy a $400 3D printer that's really good. And if you don't
Mm,
want to do that, you can go to a company like you guys, or there's a whole bunch of different ones online where you can upload your parts, you can get those made. So I mean, there's nothing stopping somebody that has a product idea from making it. The barrier to entry is
mhm,
super low.
mm,
You can figure it
mm,
out. It's really not
yeah.
hard.
Well, what are some of the things they should maybe think about before they? I know you're saying it's incredibly cheap now
Yeah.
to do that, but are there a couple of things that maybe they should think about before they do spend that money?
Yeah. I think one of the biggest mistakes I see people making when they're designing things is not designing for the manufacturing process that you're intending to use.
Right.
Um, Different manufacturing processes are good for different things, and the
Yeah.
way that the part is going to be shaped and designed, it really needs to be intended for that manufacturing process. And if you intend to jump from one prototyping technology to a different production manufacturing process, it's even a little bit something you need to put even more thought into,
Yeah. What
something
would
that
you
you can.
advise there then? Would you advise still to design for for the ultimate manufacturing process and just accept that the prototype is going to be less
That's what
good.
happens a lot of the time, that you kind of design for the final manufacturing process, and you do a 3D printing or a CNC part, and sometimes it's not optimal for those technologies, but those
Mm,
technologies are also pretty flexible. So a lot of times
mm.
that works.
Okay. Okay. And in terms of yourself, then, have you got any interesting kind of projects coming up or anything going on that
I
you're
do
keeping
all
to you?
kinds of. I work on making all kinds of different little things to fit my different needs, be it for mountain biking or motorcycles or whatnot outside of work.
Yeah. And
I do a
are
lot
they for
of.
your own personal use, or are
Those are for
you?
my own personal use, but I also help out a lot of different little inventors, startups, some of my friends that need something for their business or whatever. So I do have a little bit of a side business in doing that. That's kind of just grown out of people asking me for things, and I'm realizing like,
Yeah.
oh,
Yeah.
look, I can charge money for this
Right. Yeah.
service, you know.
Uh-huh.
Um,
Uh-huh.
but that, and then I've been tossing around an idea sort of for a software platform that assists in what I was talking about, which is kind of that Spotify, YouTube type disruption of mechanical engineering and product development. And like I was saying, it's so easy to figure out how to design something and find a supplier and whatnot right now. But a software platform that actually kind of do all that all in one place.
Right.
So
Right.
I think I'm gonna go ahead and make that this year. I've kind of
Yeah.
started.
Yeah.
So and I've talked to a lot of people, and I think there's a need for it.
Okay. Okay. So, I mean, if we want to find out a little bit more about you and what you're up to, is there somewhere we can go?
I
Or
think probably I'm the most active on LinkedIn right now, so that's the best way to find me. You can just search Justin Mitchell; it'll probably pop up Justin Mitchell Yamaha or whatever. I think
okay.
also the link works. It's linkedin.com/in/. Justin Mitchell Engineering. I think will also pull me up. That's kind of
Okay.
where I'm the most
Active.
active.
All right. Fantastic. Okay. Thank you very much, Justin. It was really
Yeah,
nice talking to you. And
you
yeah,
too.
have a nice day. All right.
Thanks. You too. Thanks for having
Bye
me
bye.
on.
Bye. Whether
Bye.
you're working on your first product or your 10th, you've got the Prototype and See podcast to back you up through your product development journey. Follow, subscribe, and tune in for our next episode. We can't wait to see where your prototype takes you.